Hello, this is Brett from SurvivalComms, and today we're going to test this radio, the Quansheng TK-11. You know, normally I do not find popular, modern, inexpensive radios of this sort interesting at all. This one, however, triggered some professional curiosity in me due to its rather impressive advertised feature set and multi-band capability. I mean, a handheld portable radio that will transmit on 10 meters, 6 meters, 2 meters, and the 70 centimeter amateur band in an FM mode is impressive in and of itself. You know, couple that with a 150 kilohertz to 1.16 gigahertz general coverage multi-mode receiver for under $100. Well, that sounds pretty impressive to me. Now, this radio also has some other catchy features like a very limited spectrum analyzer, a frequency counter with CTC, SS, DCS, decode functionality, of dual receive, dual VFO, etc. This is along with the other common contemporary FM two-way radio features. So rather than accept the one offered to me, I purchased one for myself at an expensive $90. Now we're going to go over this radio stem to stern together and see what it's all about. This isn't intended to be an instructional video and will be more focused on radio performance testing rather than feature demonstration. However, many features will be demonstrated. We will be using my personal professional test equipment in this content, and the radios used for comparison purposes are from my personal reference collection. I am not a compliance lab, and observations and opinions expressed here are my own and not those of my employer. If you have any questions, please put them in the comments. Now let's get started. So what did I get for $90? Well, I got a radio. I got a battery, which is a 2500 milliamp hour 7.4 volt lithium ion battery with a USB-C slot and a slot for the included belt clip. I got a fairly generic drop-in charger. I got a wrist lanyard, a fairly comprehensive manual, a whip antenna that covers 6 meters through UHF and uses a female SMA connector, and I got a loopstick antenna that features a 1/8 inch monaural plug. Radio construction appears solid, and it is a plastic housing over a cast metal frame. Housing is secured to the frame with machine screws, and a silicone seal is present around the battery contacts. Battery retention is accomplished by integral hooks cast into the metal frame. Now, this lends to a solid feel of the radio in the hand. Now, impact resistance was not tested, but in my opinion, it would survive a moderate drop test. Now, the control set is viewed from the front. We have a single forward-firing speaker and a microphone. A backlit multi-line display is present, protected by the housing under a separate clear plastic window that appears to be retained by adhesive to the housing proper. Immediately beneath this, we have a very large A and B button, the VFO and memory button, and a band switch. And underneath that, we have a 16-key control surface with clear to understand labels. Buttons appear to be of a rubber membrane variety. On the left side of the radio, when looking from the front, we have Band A and Band B push-to-talk buttons, which can get a bit confusing in use as configured, and below that we have two multifunction long and short duration key press buttons. Again, the buttons appear to be of the rubber membrane variety. On the right side of the radio, when looking at it from the front, we have the universal connector for this radio, which is a standard order Kenwood Baofeng connector for accessory interfacing and programming. The universal connector is protected by a stout rubber cover. On the top of the radio, we have a single switch potentiometer which controls device power and receive audio volume. The knob is slightly recessed into the housing for impact and weather resistance. To the left, we have a 1/8 inch mono plug, and this is for attachment of the provided loopstick antenna, or also for the attachment of an external antenna for receiving frequencies below 18 megahertz. Now, this connection is only covered by this flimsy rubber cover that's held by one attachment point here, and this connection point has proven problematic in testing, being overly sensitive to plug position. Now this is the cable I produced to interface this antenna connection to an external antenna, and I use an O-ring to control insertion depth. I've seen others use an RF adapter for antenna interface purposes, and this is a bad idea in my opinion, as it places a lot of stress on this rather fragile connection point. There are others who have modified this connection to use an SMA connector, and the SMA connector usually takes up space here where this LED goes. The antenna connector on top is an SMA male, and the factory antenna does a good job of sealing this connection point and working with this lip in the housing for impact protection. Now there is also a spanner nut here that is using the RF connector as a fastener for securing the frame and housing together. The battery appears to be of good construction, and battery life was good in my testing. Now, battery retention on the radio is robust and positive. The USB charging port is a nice feature, and I'll demonstrate that for you here. And it is monodirectional, meaning that it only supports charging current. So if you had any question about could you use one of these as like a battery bank or something of that nature to charge your cell phone, it will not do that. I tested that out. And the included charger is very basic. Now it's sufficient for its purpose, but I personally will only recharge this radio when I can attend the process, although no issue was noted in any of my testing. The included loopstick antenna is similar in design to the ones that are provided with the Quansheng GP5. The antenna exhibits good directivity, nulling on the ends, and then receiving strong signals on the broadsides. The antenna, when tested with an LCR meter, measures approximately 310 microhenries of inductance. Well, let's test our included whip antenna. The whip antenna appears to be of quality construction, has an SMA female connector. It also features this large loading coil, and that's to provide coverage of the 6 meter band. And overall coverage of this antenna is intended to be the 6 meter band, the 2 meter band, and the 70 centimeter amateur band. And it is not intended to cover the 10 meter band. You can see the base of the antenna and the marked frequency ranges around the base of the RF connector. Let's see if it lives up to its label. This slide is our first sweep of the 6 meter band and the antenna's resonant point. It is important to note that bandwidth of low band portable radio antennas is very, very narrow. Here is our return loss measurement of the whip on 6 meters. Now, when doing field testing of low-band portable radios, we have to consider that if the antenna isn't matched to the frequency being used by a few kilohertz, that the RF foldback protection of the portable really cuts the power back to a very low level, and this coupled with the low return loss really jams you up. This slide is the SWR of our whip on the 2 meter band, and its result isn't terrible, but it isn't good either. This slide shows our 2 meter return loss. Note the valley is only 8.87 dB. Anything below 10 dB is considered no bueno, and I am forgiving in using that metric. For comparison, I have attached an El Cheapo Sane-Sonic dual band whip and compare it to the results of the whip provided with the TK-11 on 2 meters. The return loss of the El Cheapo whip really illustrates the comparison clearly. And finally, this is our factory TK-11 whip on UHF, and it's not good at all. Our return loss measurement really shows us that this antenna has no business on UHF. So as far as the factory antenna goes, the performance was rather disappointing. Well, let's talk about the basic operation of the radio real quickly. Your control turns it on. There is like an image that you can have displayed on here and the backlight and everything. I've turned the backlight off and I've removed the image, and I've done all of that from the menu inside of the radio. You can see you've got VFO-A and VFO-B. You could switch those back and forth. The radio has dual receive, which we'll talk about that in a second. And you can select your memories here with the VFO memory key. Now you can swap bands back and forth as such. And our menu, let's talk about the menus. The general menu is basically radio settings. The channel menu is channel specific settings. The work menu are other system variables. The VFO scan, mode and frequency, memory scan, frequency scan, timeout mode, DTMF. It also has 5-tone signaling, and it also does your NOAA SAME codes if you desire to use those. And then this tells you your information about your firmware, etc. Let's go through your channel menu. Hit your menu, you get your squelch level, steps, transmit power, your CTCSS and DCS. Remember before you enter that to make sure you hit your octathorpe, your shift, your offset, wide and narrow selection. This is your shortwave and broadcast bandwidth, and this is our scrambler feature, which is just like a speech inversion scrambler, and demodulation type, and your signaling menu, and your push to talk ID if you're using their selective signaling, and your decode for selective signaling, and search list, and your memory number. Now that you understand the menu system, let's enter a frequency, hit your octathorpe, and now our frequency is entered. Now let's say we want to put in a PL tone. Hit your menu again, select your channel menu, hit your menu again, find your transmit power or your transmit CTCSS, hit your menu, hit your octathorpe, and hit your menu, and bam, you're in business. And now we've set our connect tone and our frequency for this particular VFO. The radio is capable of doing dual receive, meaning that you can receive 2 signals simultaneously. Now let's go ahead and demonstrate that for you real quickly. I'm sending a signal to this on UHF, as you can see. Let's go ahead and transmit on VHF.
Test 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Now let's play with the frequency counter functionality. You hit the 3 key,
Scanning begin.
and it's going to tell you it's beginning scanning, and it's looking for another signal. And there it's found it, and it's showing us our PL tone, just like that. One of the other unique features of this radio is it has a small spectrum analyzer in it. So to access that, just hit your 7 key, and you can see our display here. C is your center frequency, R is your reference level, S is your span, and M is your marker location. And whenever you turn this on, whatever band or whichever VFO you have selected is going to be the frequency that's going to show up on here. So let's go ahead and change our frequency. So you just hit the 1 key, and let's go ahead and make that for the weather channel. Then save it. Now let's go ahead and change our reference level. We hit 2, and then use your arrow keys to drop it reference level down, and now you can see we're picking up our signal. And now we can go ahead and change our span, 640 kilohertz. And you can see these little tiny pips down here, and these are our signals here, and it's just above the noise floor. And you can see that the signal receiving here is 162.550 megahertz at a signal strength of negative 118 decibel milliwatts. So, kind of an interesting toy to have. The radio also supports PC programming. Here are some screenshots of the software. The software was easy to use and reliable in my testing, but one thing that I did notice was that the radio requires a CH340 chipset Baofeng cable, and I was unable to get an FTDI chipset cable to work at all on several programming platforms. The radio also supports radio-to-radio cloning over the air. The default frequency is UHF, and it's not on a frequency you should use in the US. I did not test this functionality, and it's time to move on to the main event and test this radio. Let's start with our rated audio test. Right now we're just under about 9/10 of a watt of audio power, and you can see it's all blown out. So as we reduce to about 3/4 volume right there, we're much better. Now moving on to our service monitor testing of the TK-11 on transmit. This shows us the frequency error, RF power output, and FM deviation at a glance. In this example, we are testing transmit at 28 megahertz for a 25 kilohertz channel spacing. I have marked the slide showing plus 3 hertz of frequency error, which is excellent. The RF power is 4.7 watts, which is good, and the FM deviation is 3.25 kilohertz, which is slightly under deviated. It should be 3.7 to 4 1/4 in a 25 kilohertz channel under 80 millivolts, 1 kilohertz tone. This leads me to believe that the wide channel spacing in this radio is for 20 kilohertz split rather than 25. Moving on to 6 meters, we are plus 4 hertz of RF power, and it's the same as 10 meters, and we are still under deviated. Now on VHF, we are plus 8 hertz of RF power, which is now 8.1 watts, which is within the radio specification window, and the FM deviation is consistent. This is UHF, and we are plus 2 hertz of RF power, 7.1 watts out, which is still within the specification window, and the deviation remains consistent. Now this slide is VHF set for narrow FM, and the results are what we would expect. And the deviation is still a bit low, but demonstrates that the transmitter actually reduces deviation when instructed to. And for comparison, this is my Kenwood THD74. The frequency error is plus 2 hertz, power is 4 watts, and our FM deviation is 3.88 kilohertz. Now we're going to perform a subjective transmitted audio quality test. The receiver we're going to use is my ICOM ICT70A. The first transmission you're going to hear is going to be from the TK-11, and then we'll let you hear a transmission from the Kenwood THD74.
Rhinoceros, this is Platypus. I am marsupial at this time. Over. Rhinoceros, this is Platypus. I am marsupial at this time. Over.
Well, let's test spectral purity of our TK-11 radio, and first we're going to show you a best case scenario as a control here. This is my Motorola Apex Next, and this represents just about as good as you're going to get in a test such as this. Our fundamental frequency, it's 37.41 decibel milliwatts, which is like 5 watts of power. Now if we go to our second one, we can see that right there is our our second harmonic. That's negative 28.23 decibel milliwatts, and that's excellent. That's like 65 dB below our fundamental frequency, which is incredible performance. And then moving right along, you can see we're fine here. Now when you're looking at each one of these harmonics besides the fundamental, you want to keep each one of these below negative 16 decibel milliwatts, which represents that 25 microwatt horizon. So just keep that in mind when you're looking at our testing. Well, here is the spectral purity, or impurity as it were, of the TK-11 on the 10 meter band. Our fundamental is 36.6 decibel milliwatts. Second harmonic at 56 megahertz is 10.98 decibel milliwatts. Our third is 1.88 decibel milliwatts. And our fourth is minus 2.95 decibel milliwatts. And things have not improved for us on the 6 meter band either. Our fundamental is 37.3 decibel milliwatts. Second harmonic, 8.64 decibel milliwatts. Third harmonic, negative 10.86 decibel milliwatts. And our fourth harmonic, negative 9.42. For comparison purposes, I'm going to show you what my Motorola HT-1250 does on the 6 meter band. Our fundamental, 36.76. Our second harmonic, minus 27.76. Our third harmonic, minus 34.16. And our fourth harmonic, minus 33.72. So let's look at our TK-11 on VHF fundamental, 38.84 decibel milliwatts. And our second harmonic, minus 14.38. Next, minus 13.74. And our third or fourth harmonic, minus 20.82. Now for comparison at VHF, we're going to use my Kenwood THD74, and you can see our fundamental is 36 decibel milliwatts. Our second harmonic, negative 32. Our third, negative 29. And number 4, negative 35.02. And finishing off at UHF, marker 1 is 38.38 decibel milliwatts, and marker 2 at 1.3 gig is minus 24.27 decibel milliwatts. Now we are going to begin our receiver testing, and we will be looking at what level of signal is required to maintain 12 dB of SYNAD. This is considered to be the level of signal required to maintain speech intelligibility and is a standard measure of receiver sensitivity. This slide is what 10 dB of SYNAD looks like on an oscilloscope connected across the load that my SYNADer in the previous slide was measuring from. This slide is our measurement on 10 meter FM. Marked is the RF applied at the top, and marked in the middle is the measured SYNAD. In this example, the signal supplied matches the specification outlined in page 25 of the manual. Next is 6 meter FM, and we are below specification, requiring 4 dB of a signal greater to achieve 12 dB SYNAD. Next is 2 meter FM, and we are below specification by 0.6 of a dB. Next is 70 centimeter FM, and we are below specification by 0.8 of a dB. As a comparison, here is the Kenwood THD74 on VHF, and you can see our measurement falls a few tenths of a dB below the TK-11, but in reality we are splitting hairs considering tenths of a dB. Here is a curiosity is our FM performance in the 800 MHz band, and the radio is deaf in this range, requiring a very strong signal to achieve 12 dB of SYNAD. This next slide is our measured sensitivity in an AM mode for AM broadcast band, HF, civil aviation, and military aviation. For AM broadcast band, The bandwidth limitations prevent the radio from having good fidelity, as you can see here when compared to the CountyComm GP5.
Pulling up a shot, a live look at the Everglades in Florida. If you're watching on Salem News Channel, you can see all that water. There's a bunch of racist alligators swimming around into that water. There's a bunch of racist alligators, according to Axios.
Save space for the younger generations to grow professionally while maintaining a strong Christian foundation. Join the Central Florida Christian.
Now here is a comparison of HF receive on single sideband between the TK-11 and the Kenwood THD-74. Now here's an example of audio captured with the TK-11 on the civil aviation band.
250, stopping it at 25,000, 260, habitat.
Yeah, center is at 828. Up ahead about 25 miles, we're going to need about 10 left. Heading 280, that's at 828, thanks.
Now we're going to perform a relative selectivity test of the receiver. We're going to generate a signal at minus 100 decibel milliwatts, modulated with a 1 kilohertz tone on the tuned frequency of the receiver, and then we're going to take our signal generator and step away from the tuned frequency until our signal disappears. Squelch is open, signal on, 5 kilohertz, 10 kilohertz, 15 kilohertz, and our signal is gone, 16 kilohertz from the tuned frequency. Now let's repeat the test with our Kenwood THD-74A. Signal on, 5 kilohertz away, 10 kilohertz away, and 15 kilohertz away. Now we will perform a relative adjacent channel rejection test. This simulates how our radio will perform when receiving on the receiver's tuned signal and a much stronger signal 25 kilohertz away from the tuned frequency begins transmitting. We are using two signal generators connected to our device under test through an isolated signal combiner. Our tuned signal is a minus 110 decibel milliwatt signal modulated with a 1 kilohertz tone, and our interfering signal is a minus 70 decibel milliwatt signal modulated with a 500 hertz tone. Ideally, there should be no degradation of our signal when the interfering signal is present. Well, let's begin our test. Squelch is open. Volume up. Primary signal on. Interfering signal on. Interfering signal off. Now let's repeat the test with our Kenwood. Primary signal on now. Interfering signal on now. And you can see there's just very slight degradation. Second signal off. If you made it this far into this content, thank you. This is going to be a brief rehash of my impression of this radio and the test results you just saw. This isn't a death by PowerPoint, so fear not. You will have invested enough of your time. Feel free to stop and read the slides if desired. Physical package of the radio is good, and that is the opinion of my peers as well who have been able to handle the radio. The display is good and isn't excessively busy and can have details reduced through programming if desired. The second push-to-talk can be confusing to the end user and lead to inadvertent transmissions, but again, programming can resolve this by deactivating it. The volume control on-off knob has very little tactile feel in powering the radio on or off, and in reducing volume, it is possible to turn the device off and not realize it. The HF audio jack used as the HF antenna connector is poorly executed, in my humble opinion, and that seems to be a common consensus with others. I didn't do any destructive drop or water immersion testing, but it is my opinion that the radio can handle rain and a moderate drop. Battery appears solid and functions well, but again, it is brand new. The USB-C port is nice, and this is, however, another ingress point for debris and water. The charger is very basic, and that worked fine in testing. Now, my personal policy on lithium-ion battery charging is that it takes place in a common location where there is some oversight during the process. The user interface of the radio is good and intuitive. Some bugs were noted, for example, in tuning the AM broadcast band. When you change the channel step to 10 kHz, the radio is mistuned by 3 kHz on the display, necessitating selection of the default 1 kHz step. Direct frequency entry works fine. I mentioned the necessity of using the octathorpe, which is your pound sign, for entry of selective DPL, PL signaling particulars as well. There may be some others I missed. The radio is feature-rich, and a proper flow chart would be enormous. The software was intuitive, easy to use, and basic manipulation of features, channel edits, and read-write cycles went without a hitch. The necessity of using a programming cable using a CH340 chipset was something I wanted to make mention of again. I attempted to use 3 different FTDI cables and multiple programming platforms without success. The cable I used with success was a $7 TID radio cable that uses the 340 SER driver. The antenna, the provided AX1 antenna was not a good performer in testing, as you saw, and the loopstick was good for the AM broadcast band. Transmitter testing showed us that the frequency stability was excellent. The max error observed was plus 20 Hz at UHF. The RF power was within specification, and the radio is under-deviated, and the transmitted audio being muffled is a symptom of this. Microphone gain settings did not alter this in my testing. Observed spectral purity of this radio in my testing is not good. Some users may not care, but in my opinion they should. The tuning agility of the transmitter section of this radio can put you into places where harmonics of the magnitude observed can interfere with fixed and licensed services. Again, I'm not a compliance lab, and your mileage may vary. Receiver performance is good. The receiver was very close to its published specifications in most places, and its relative selectivity and adjacent channel rejection were on par with the Kenwood THD-74 in my testing. My biggest gripes were in the bandwidth selections for CW and AM broadcast band in the expanded receive category. The above UHF receiver insensitivity isn't unique, as many amateur radios that tout extended receive capability suffer this same shortcoming. Thanks for sticking it out if you made it this far, and if you have any observations of your own on this radio or experience with it, or if you have any questions for me, please let me know in the comments. I hope this helps. This is Brett from SurvivalComms. Until next time.